This volcano is so notorious that most people know at least something about it. Often it boils down to some familiar snippets of information, such as an unfathomably loud explosion, a monstrous tsunami, terrible loss of life, and, in the aftermath, beautiful sunsets around the world. But although these things are all broadly true, there is a lot more to this story. When the eruption began at 6 a.m. on that Sunday morning, it took a little while before its location was pinned on Krakatau. Indonesia has always had prolific seismic activity, so any warning signs in the run-up to the 20th of May probably didn't stand out as unusual. Just a few weeks earlier in April, Mount Lamongan had erupted down in southern Java, and early May had seen earthquakes and tremors in northern Java and southern Sumatra. In many ways it must have just felt like business as usual. The Sunda Strait of the 1880s was a very busy shipping route, so there are plenty of maritime records to draw on. Pillars of smoke and ash were reported several times prior to the 20th of May, but perhaps because Krakatau had been quiet for so long, there was no significant alarm. Nobody could have imagined that the start of September that year would see hundreds of coastal communities washed away and many tens of thousands deceased. Although this eruption was very well documented for its time, some information was never recorded or has been lost for good. This is the case regarding the topography of the island before the eruption. So to help us picture what went on, I've made this miniature of the pre-1883 island. The eyewitness observations and sketches of the island vary somewhat, so this model is a distillation based on the available details. At this point, I'd like to thank Professor Steve Self of the University of California, Berkeley. Steve's a volcanologist and research scientist and has worked extensively on this eruption and many others like it. He's been most generous with his time, and this series just wouldn't have been possible without his help. So thank you very much, Steve. Back in 1883, Indonesia was known as the Dutch East Indies, and so a lot of places were given Dutch names. For example, the capital Jakarta was known as Batavia. For simplicity, I'll be using period names throughout this series. However, if you decide to read up about this later, you will find that some places which kept their Indonesian names have also since been renamed. I'll say more about the islands in the Krakatau archipelago shortly, but first let me mention its immediate neighbours. These are Sebisi at just 20 kilometres away and Sabuku at about 28. Still further away, on southern Sumatra, are the mainland settlements of Ketimbang and Telok Betung, and Anya and Charangin on northern Java. If we go a little further round the Java coast, there's the capital Batavia, some 160 kilometres from the volcano. Seen from above like this, it's immediately apparent why Krakatau's 1883 eruption was so destructive. This volcano has a captive audience of coastal settlements with deep bays and coves, ideal for focusing the effect of large waves and pyroclastic clouds. What we have here is a hand grenade in a fish tank. Regarding the way our planet behaves, Professor of Geology and Environmental Studies Mike Rampino summarized it perfectly. He said, "There's a kind of rule in geology that the more beautiful the landscape, the more dynamic the processes are that created that landscape." Krakatau Island was a good example. It was, by all accounts, stunningly beautiful, and from what's known of its history has been very dynamic indeed. The two other islands in its group are part of a caldera. the remainder of an earlier, very destructive eruption. It's thought that a single, quite large volcano once stood on the spot that would later become Krakatau Island. There are many different ideas about what happened in this region before the appearance of this island. A couple of dates in the 5th and 6th centuries have been considered, but there's nothing that can button down exactly what happened or when. All we can say with any certainty is that after some major eruption cycles in prehistory, 3 neighbouring volcanoes appeared at the same location, eventually merging into one island with 3 cones. Incidentally, if you're wondering why I call it Krakatau, that's because the name Krakatoa was an invention of the Royal Society of London for its lengthy report on the eruption. Not everyone involved was happy with this anglicisation, but somebody wielding a red pen insisted on it. Krakatau has always been the true name of this volcano, and of course its offspring at the same location is called Anak Krakatau. Indonesia is the most volcanic country in the world. It sits right at the intersection of several tectonic plates and is littered with volcanoes both active and dormant. The exact mechanisms of the various intersecting plates are the subject of ongoing debate, but let me just call attention to this line here, where the Indo-Australian plate subducts under the Eurasian plate. The country has some 140 active volcanoes, many of them, including Krakatau, located along the Sunda Arc. Krakatau was both the name of the island and that of the group within which it sat. There was Krakatau in the middle, Selatan or Setung in Indonesian, Lang or Rakata Kersil, and a little islet that the Dutch called Polish Hat. By 1883, Krakatau had long been thought extinct. Its last eruption had been in 1680, but was probably quite modest, with local ashfalls and floating pumice. From 1809, the island served as a prison colony for about 10 years. There was a hot spring, but no record of the island being considered dangerous. People from the other islands would arrive by boat to harvest wood and trap animals and birds. The island itself was about 8.5 by 5 kilometres. At the northern end was Perbuatan, 120 metres above sea level. This was the area that began erupting on the 20th of May. Towards the middle of the island was Danan at 450 metres. Danan and Perbuatan were the most active areas in this eruption. I say areas because this eruption wasn't confined to the cones, but came from a number of additional vents that opened up as the cycle progressed. Finally, at the southern end was Rakata, the largest of the 3. It stood at 820 metres above sea level, and although much bigger than the other 2, it's thought that if this cone erupted at all, it may have been supplied by a secondary tube, perhaps from Danan. This means that Perbuatan and Danan were probably located right over the magma chamber, with Rakata offset from it, which could explain why part of Rakata survived the final collapse of the island. Just jumping ahead for a second, this map was sketched in mid-August and shows 14 active vents on the island. It's a good indication of how much pressure was trying to get out and how serious things would eventually become. Krakatau was considered a permanent fixture of the Sunda Strait, and nobody alive could remember it ever having erupted. So, after 203 years of sleep, why did it wake up? This question would be debated for many decades. Initially, it was considered that seawater must have penetrated the magma chamber, causing a violent reaction and blasting its way to the surface. These kinds of magma-water events are known as phreatomagmatic eruptions, and for many years this was a popular explanation of what happened here. But as time went by and new research was conducted, it became clear this was unlikely. Based on the geological evidence laid down during the 1883 eruption, a more probable explanation is what volcanologists call magma mixing. In magma mixing, much hotter, heavily gas-laden magma infiltrates the space occupied by, relatively speaking, cooler magma and causes pressure to build up. In Krakatau's magma chamber, it seems that hot, dark and somewhat thinner basaltic magma intruded into the same space as lighter-coloured, thicker dacitic magma. The two types churned over together, releasing a lot of dissolved gas and causing a massive overpressure. Once the magma broke surface, all those dissolved gases were suddenly and violently freed. With superhot pressurized gas building up so rapidly, this volcano was destined to erupt very violently and via any available route. Next time we'll be hearing about a group that visited Krakatau soon after it began erupting. They found the cone of Perpotan to be emitting gas and smoke, although, as we'll hear, it's likely that multiple vents were already opening up. And this was just the beginning.